Hello students, let us discuss an important concept in the chapter Structure of Atom, that is valency. Valency word is already we have discussed in the chapter Atoms and Molecules. We have defined the combining capacity of an element is known as its valency. If you remember, we have done the crisscross method to find out the formula of any compound. In that, the valency we are doing crossing here. So that actually is giving rise to the formula. So combining capacity of an element is known as its valency that we have discussed. So the question arises, why 3 is the valency for aluminium? Why 2 is the valency for oxygen? So why we are keeping 3 as a charge for aluminium, that is 3 positive, why we are keeping 2 negative for oxygen? So that we need to discuss here. So little bit in the more detail we are going to discuss about valency. So let us start the topic valency. As it depends upon the structure of atom. We have already discussed that in atom the nucleus is present at the center and electrons are revolving around the nucleus in a definite path which is called as orbits, which are K, L, M, N and so on, and the maximum number of electrons which can be accommodated in these orbits are 2, 8, 18, 32 respectively in the shells K, L, M, N. So on the basis of this, we have already discussed the structure of the atomic structure for the different elements we have done. So according to the octet rule says that the maximum number of electrons that can be accommodated in the outermost orbit is 8. So that in an atom, the outermost shell must accommodate 8 electrons, then it will be the more stable form. Except the case of helium, in which the maximum number of electrons which can be accommodated in the first shell, that is 2, because only in the exception is helium, it is stable only by 2 electrons in the outermost shell. So as according to the octet rule says that the one atom is stable when it is getting 8 electrons in the outermost shell, except helium, because in helium it is stable by getting 2 electrons itself. That is, here the concept of 8 is not applicable here, except in the case of helium. So in other all atoms, it must get octet, that is, it must get stable by getting 8 electrons in its outermost shell. Let us take one example, that is argon. In argon, the atomic number, that is the number of electrons present in it is, that is 18. So when you arrange the electron in the first shell, 2 electrons. In the second shell, there are maximum 8 electrons it can be accommodated. So 8 electrons. In the first it is 2, in the second it is 8. So which is the outermost shell here? That is the third shell is the outermost shell. So 2 plus 8, that is 10. How much electrons are remaining now? Because total it have 18 electrons. So 8 electrons are remaining. That 8 electrons are there in the outermost shell. So the case of argon, here already it have 8 electrons in the outermost shell. So that is, it is the stable form. That is, this type of configuration is, we can say that it have a stable configuration. Why? Because its outermost shell having 8 number of electrons, as you can see here. So it already have 8 number of electrons in its outermost shell. So we can say that it is a having stable configuration. So that type of atoms are stable in nature. So that's why we can get argon in the nature in the stable form. That's why they does not combine with the other element because they are already stable in the nature, because they have 8 electron in the outermost shell. It means that they have a stable configuration, so it does not combine with other atom. So what is its combining capacity now? It's 0. Therefore, its valency is equal to 0. So that's why argon in the nature, it is formed in the monoatomic form. As we have discussed in the chapter atoms and molecules, helium, argon, these are the elements which exist in the nature in the monoatomic form. Monoatomic form means they are existing in the nature as a monoatomic form. That means it is not combining with the other element. So its combining capacity, that is valency, is equal to 0. But the case of sodium, total number of electron is 11. So from this, 2 electrons are there in the first, 8 electron are there in the second shell. So how much is there in the third shell? That is only single electron is present in the third shell. Now, is it stable now? No, because according to the octet rule, the outermost shell, that is the third shell here, outermost shell should get 8. Then only it will stable. So here there is only one single electron is there. So we can say that it is not stable one. So how it stabilize? Because in order to get stabilized, it needs 7 electron in the outermost shell. But it is not possible to get 7 electron very easily. So instead of gaining the 7 electron, because already 1 electron is there here. So instead of gaining the 7 electron, it is better to lose 1 electron. So it will lose 1 electron, that is in the outermost shell. It is lost 1 electron. Now when it loses 1 electron, so it develops a positive charge. Therefore, it is a sodium ion, that is represented as Na+. So how Na+ is developed? That is due to the loss of electron by the sodium atom. So sodium atom, that is Na, lose 1 electron in the outermost shell. Now you can see the outer shell is removed. So now you count it, how many electrons are there in the outermost shell? Now there are 8 electrons in the outermost shell. Now it is stable. Now we can say it is satisfied. And it results in the formation of ion, that is positively charged ion, which is called as cation. So how the cation is formed? That is due to the loss of electrons, cations are formed. That is, the sodium ion is an example of cation. So from this it is clear that why the cations, how the cations are formed. When an atom loses electron, it forms cation. So we can say that the sodium atom having the 1 electron in the outermost shell, it loses 1 electron to attain the stable configuration. So its combining capacity is 1 because it is losing 1 electron. Therefore, its combining capacity is 1. Therefore, we can say that its valency is equal to 1. So from here it is clear that why sodium have a 1 positive charge? Because with the loss of 1 electron, it forms the stable configuration and it develops a 1 positive charge. 1 electron is lost, 1 positive charge is formed. So the valence is 1. So that is in the case of sodium, the valency is 1. What about the valence electron? Because in the outermost shell, there is only single electron. Therefore, the valence electron is equal to 1. So in this case, valency and valence electron, that is equal to same number, that is 1. So for some atoms, the valency and valence electron will be same. But let us take the case of oxygen. In the oxygen, total 8 electrons are there, 2 electrons in the first and 6 electron in the second shell. So tell me whether it is a stable configuration, it have a stable configuration or not? Definitely not, because in order to stable, outermost orbit should have 8. Does it have 8 in the outermost? Count it, 1, 2, 3, 4, 5, 6 only there. So definitely what happens here, 2 more electrons are needed. So instead of losing the 6 electron, it is better to gain 2 electron. So it gained 2 electron like this, which I marked with red color dots. So it gained a 2 electron, and because of the gaining of 2 electron, it developed a charge that is 2 negative charge. So now this is called as a negatively charged species, which is called as anion. Now this is called as anion. So how the anion is formed? When an atom, that is an atom, gain 2 electron, it forms negatively charged ion. It forms negatively charged ion, that is called as anion. So the combining capacity here, because there are 2 electrons are gained in order to attain a stable configuration, so its combining capacity is 2. Therefore we can say that its valency is 2. Why it is 2? Because 2 electrons are gained, so valency is 2. Tell me whether here valence electron and valency are same or not. What is the number of valence electrons here? That is equal to 6. As we have already discussed, valence electrons are the number of electrons present in the outermost shell. As in this case, already 6 electrons are there. That is for the case of oxygen atom we are discussing here. Already 6 electrons are there. So valence electron is 6, but these 2 electrons are the gained electron. So valence electron is 6 and 2 electrons are gained. So valency is 2, valence electron is 6. So don't get confused. Valence electron is the number of electrons present in an atom in the outermost shell, that is 6 for oxygen. But in order to attain the stable configuration, it gains 2 electron. That's why its valency is 2. So 6 is the valence electron, 2 is the valency. So in this case, valency and valence electrons are not same. So we have learned that loss of electron forms positive charge, gain of electron form negatively charged ions. Let us take an example, carbon. In carbon, total 6 electrons are there, 2 electron in the first and there are 4 electron in the outermost shell. So here the valence electron is 4. So the question arises whether it gain 4 electron, because in order to get 8, does it gain or does it lose? Because 4 gaining or 4 losing, which is more possibility here? When the number is less than 3, then in that case losing is preferred. But when the number of electron is more than 4, then gaining is possibility. But when there is 4 electron, in that case it shares electron with the other atoms. Like the case of carbon, it need 4 electron. So these electron will be shared with the electron of other atoms like hydrogen. So in the case of hydrogen, single electron is present. So hydrogen want to get stable by getting 2, because in the first shell maximum 2 electron can be accommodated. But carbon needs 8, so it share 1 its electron with 1 electron of 4 hydrogen. So we can say that it shares electron. Shares electron mean now both are contributing this electron, that is both get satisfied here by sharing the electrons. So we can say that in this 4 electrons are shared, therefore its combining capacity is 4 and its valency is 4. So from this it is clear that the valency can be, it is the number of electron lost, number of electron gained, or the number of electron shared. So let us take some examples, and now we are writing the examples with the electronic configuration for the better understanding. Sodium electronic configuration 281, that is 281. We have already discussed the electronic configuration. In the outermost shell there is only single electron. So what it will do, it, in order to get stable, what it will do, it lose one electron and form sodium ion. Now you can see here 2 8. Where is the one electron? This electron is lost. So we can say that now its configuration become 2 8. Now the outermost shell having 8. It is stable. Now this one is stable. So why it is losing the electron? In order to attain the stability. So the atoms are combining in the nature by losing the electron, gaining the electron, or sharing the electron to attain stability. Like the case of sodium here. So with the loss of one electron, the sodium attains the stable configuration. It results in the formation of sodium ion, that is a cation. Aluminium, the configuration is 283. Here 3 electrons are there in the outermost shell. You can see here 3 electrons are there. So in order to stable, it require, how much electrons are required? Already 3 are there. So 5 electrons are required. So does it gain the 5 electron? No. Instead of gaining the 5 electron, it lose 3 electrons. So what it forms? It forms aluminium ion. Now you can see here how much is the charge? 3 plus. When it lost single electron, then it form 1 positive charge. When it lose 2 electron, then it form 2 positive charge. But here 3 electrons are lost. So it develops 3 positive charge. Now it is clear why aluminium have 3 positive charge. Why it have valency 3 positive, or that is 3, because in order to attain stability it lose 3 electrons. Now you can see its configuration 2 8. Now the outer one have 8. So the octet is complete, therefore it is stable configuration. Oxygen configuration 2 6. 6 electrons are there in the outermost shell. So how much is required to get stable? 2 electrons are required. So better it will gain. So when it gain the 2 electron, it form, that is, it form oxygen ion, that is oxide ion. Now you can see 6 electron is here, but now here it is 8. So how it become 8? Because here 2 electrons are gained, that I have shown here with the red color. 2 electrons are gained. Now it have 8 electrons in the outermost shell. So here they are stabilizing by gaining of 2 electrons. So its valency is 2. So how we can define the valency? Because the valency in some cases are the number of valence electron. In some cases we can say that it is not equal. So the valency can be equal to the number of electrons gained, lost, or shared. And this is actually responsible for the combining of these elements with the other elements. So that is, it results in the formation of bonding. So we can define the valency in the different way. Like valency is the maximum number of electrons that an atom can lose, gain, or share to become stabilized. That is one of the definition, important definition. Already we have discussed the valency definition. It is a combining capacity. But that definition is not enough. In more detail, when we discussing the valency, how we define it? Valency is the maximum number of electrons that an atom can lose or gain or share to become stabilized, as we have discussed in examples. And it can also explain the formation of bond between the atom, like why the water is forming two bond with the hydrogen. So that type of bonding can be described by the valency. That is, valency is explaining the formation of bond between the atoms. Valency for a pure element depends on the number of electrons present in the outermost shell, because valency we have calculated, that is the number of electrons shared, gained or lost. So that is actually depend upon the valence electron. So if valence electron is 1, it will lose 1 electron. If valence electron is 2, it lose 2 electron. If valence electron is 3, it lose 3 electron. But if the valence electron is 4, it share the 4 electrons. If the valence electron is 5, at the time it gain electron. How much electron it gain? It gain 3 electron, because it want to get 8. So it gain 3 electron. If valence electron is 6, then it gain 2 electron. If valence electron is 7, it gain 1 electron. So we can say that the valency depends upon the number of electron present in the outermost shell, that is the valence electron. So we can say that valency depend on valence electrons. So better we will make this chart. We have already discussed this table in which we have learned the valence electron, how we have learned the sequence. On the basis of this, we can compare the valence electron for these like this. Once you have learned the valence electrons, you can easily make or easily you can predict its valency. Its valency will be in this way. That is, if 1 is the valence electron, it lose 1 electron, so valency is 1. If 2 is the valence electron, it lose 2 electron, so valency is 2. 3 is the valence electron, it will lose 3 electron, so valency will be 3. But when there is 4 electron in the outermost shell, it shares the electron. And when it is more than 4, then in such case gaining is taking place. So what we can say that from this table, when the valence electron from 1 to 4, if the valence electron is 1 to 4, in that case the loss of electron, that is between 1 to 4, loss of electron takes place. And if it is more than 4, in that case gaining of electron takes place, and for 4 sharing is taking place. So better we can learn in this way. Less than 4, losing of electron. More than 4, gaining of electron. If it is 4, sharing of electron. So that is we can say that valence electron is connected to valency. So it is very important point to remember valence electron, valency. Better learn 1 to 18 elements valence electron, valency in this way. So it will be better for learning. So this is all we have discussed about the valency here, and we have discussed how the valence electrons and the valency are connected. So this is all about this video. Have a nice day.